So in the previous video, we've seen that when given 2 points, when given 2 points, we can extract a vector. And then you can describe any point on that line by having a starting location. So this would be your starting location, and then you've got your vector here. So you can times this vector by whatever amount, and t could be infinity, could be less than infinity and greater than negative infinity. So t can exist anywhere in between the two. So if you want to go in this direction, you would insert a negative number into the t. So in this video, I want to illustrate something to you. Let me just translate this thing into 2D. So let's say we've got a starting location. So this is our starting location, but this is our vector here, 3 across, 1, 2, 3, and then 2 up. So rather than so this is our vector here. This is our vector. If you insert, let's say, a 3 into here, it would be 1, 2, 3. It would then take you. Your starting location is here, and then if you insert a 3 in here, it would take you to here. But let's say I don't want to go all the way from here to here. Let's say I just want to go 90% of the way. So let's say 90% is here. Then I would insert 0. I would insert 0.9 into the t. So this is our starting location. 2 across, 1, 2, and then 1 up. This is our starting location. If I want to just jump 90% of the way, then if I wanted to describe this point, then I can look at it in terms of the x direction and in terms of the y direction. So me wanting to go to here, an alternative way of getting to this point is to look at this in the x direction, look at it in the x direction only, and then later on look at it in the y direction only. So another way of describing this point here. So one way of describing this point here would be start here, which would be this location, times 0.9 plus, and then you would insert 0.9 into here, and then this whole thing here. Well, this whole thing here will then take you to here. An alternative way is to look at it, look at the x component. So so you would start at the origin. So plus 2. So that will then take you to here, and then just looking at, we've got this vector here. But you can consider the x components only. So me wanting to go 90% of the way is the same as me wanting to go 90% in the x direction. So I'm just going to go 90% in the x direction. That will then take me to here. So going 90% in the diagonal direction, it's the same as me going 90% in the x direction and 90% in the y direction. 90% in the y direction. So you can, it will take you to the same place. So the point here is that this is one way of describing this point here. You would start at your location, and then insert 0.9 into here. That would then take you 90% of in the diagonal direction. An alternative way is to start at the origin, and then go and just consider looking at it in the x direction. So go 2 across, and then go this amount across in the x direction, and then in the y direction, go 3 up. Hang on, let me think. Sorry, I made a mistake. Go 1 across. So this should be a 1 here. Sorry, I made a mistake. Yeah. So this could be this is a mistake here. So that's going. Let's start again. To describe this point here, we could go 2 across, 1, 2, and then this amount across. So that's in the x direction, and then in the y direction, go up 1, and then this amount up. So that will then take you to the same place. The point is that going 90% in the diagonal direction is the same as you going 90% across here, and then 90% of this vector here. So going back to here, hang on. Going back to this point here, let's say you're starting here and you want to describe this point here, which is 90% of this vector here. So you want to describe this point here. So let me think. Bear with me. So you wanting to go 90%. Um, so our old way of doing it would be to start here, and then insert a 0.9 into here. So that will then take you 90% of this vector. That will then take you to here. An alternative way is to consider the location of the x in the x direction, in the y direction, and in the z direction. So hang on, bear with me. So you wanting to go 90% along the diagonal is the same as you wanting to go. Hang on, let me think. So an alternative way is for you to start at the origin and then consider the x direction only. The x direction would be you going 2 across, so 2 across, and then 0.9 times the x component. So that would then take you to hang on, let me think, to somewhere around here. That would take you somewhere around here. Now consider the y direction. The y direction would be you moving across 1, so 1, and then 90%. So you moving across 1, so that's you moving across 1, and then 90% of the y component of the vector. So 90% of the y component of this vector. So that would be this bit here. So that would be roughly somewhere around here. And then looking at it in the z direction, well, the z direction would be you moving 5 up, 1, 2, 3, 4, 5, somewhere around here, and then extracting 90% of the z component of your vector, which is this thing here, 90% of the z component of your vector. So that's this bit here would then take you to the same location. The point is that you can just consider 90% of the x component of your vector, 90% of the y component of your y, whatever, and 90% of the z component of your vector. So that will then take you to the same place. So the good thing is that this thing here tells you the precise location in the x direction in 3D space. You see here with our old method, we would start here, and then everything relates to this point here. So we would times 3 of the vector starting from this location. But with this method, you know the precise location in 3D space. It is this amount in the x direction, and then in the y direction this amount, and then in the z direction it would take you straight to here. So with this method, you know precisely where it is in 3D space. This method is so relative to this starting point. Okay.